In this recording, we're going to get an introduction to the reciprocal trig functions. So you already know about the sine, cosine, and tangent. Those are our primary trig functions. But it turns out we can also take the reciprocal. You know, we have like for sine y over r. We can take the reciprocal of that, r over y, and give that a name. And that's what we've done here. Each of these new trig functions is the reciprocal of one of those primary trig functions. So we have secant, which is the reciprocal of cosine. It could also be considered, because cosine is x over r, could be considered r over x. Okay, of course, r would be the hypotenuse of that triangle. Cosecant, well, that could be considered the reciprocal of sine. It could also be considered r over y, okay, where we have this. If you're wondering where are these r's and y's coming from, basically envision, and we've done this before, but I'll refresh it for you. You've got a theta here. That is our reference angle of a angle in standard position. This, of course, would be the y. This would be the x. This would be the r, the hypotenuse. So secant would be the ratio of cosecant would be the ratio of r over y. And finally, cotangent. Well, that's the reciprocal of tangent. Now, tangent was TOA, right? Y over x. So flip that around. X over y. Okay? It's cosine over sine, or you can just say it's 1 over the tangent. Okay, so I don't want to do too much with these reciprocal functions, so I'm going to kind of pick and choose a couple of these questions for us to do. Let's consider this middle one here, cotangent of 150 degrees. So let's first think about a 150 degree angle in standard position. So why don't you sketch out where that angle would be, label all the sides that you know from that special triangle, and then play the recording when you're ready. Okay, so hopefully you set something up here. So now that we have this triangle, we can think about what cotangent is. Well, cotangent is the x over the y. So that would be the square root of 3 over 2 over the half. Which is negative up here, over the half. That creates what we call a complex fraction, a fraction that has fractions within its numerator and or denominator. Well, we can resolve that by basically making a division, right? So this is basically this numerator divided by this denominator. So I'm going to call it negative square root of 3 over 2 divided by a half, which we know from way back when is the same as multiplying by the reciprocal of the divisor. Well, that's nice because the 2's are going to divide out, and we just have an answer of negative square root of 3. We can confirm this with our calculator. So if you have a graphing calculator, grab it. I'm going to come over here to the home screen. Let's get and check our mode. We need to be in degree mode because we're about to enter a degree angle. We're going to enter cotangent. Well, there's no cotangent button, and it's not this blue button. That's for when I know the ratio and I want to find the angle. That's the inverse tangent. That's different. So what we want is 1 over the tangent. Remember, I don't have a cotangent button, so I need to express cotangent in terms of sine, cosine, or tangent. So like if I wanted to find secant of 60, like in this problem, I could do 1 over cosine of 60. It's just that my calculator is not necessarily going to give me a expression of the answer if it's irrational like this. It's just going to give me the decimal. So back to this problem, cotangent 150. We're going to enter it as a fraction. 1 over the tangent of the angle 150 degrees. You might say, well, I'm not sure if that's right. Well, let's go ahead and type in negative square root of 3. And yeah, that checks out. Okay, so I think I'm going to leave the other two alone for now. In terms of entering this one, well, this one's not going to be something we would do by a drawing because 52 degrees is not going to result in a special right triangle. So let's go right to our calculator. The secant of 52 degrees, think about how you would enter that in your calculator. Even if you don't have a calculator, think about what of these three functions could be used to find a secant, and write an expression that you would type in the calculator. And play the recording when you're ready. Okay, so hopefully you took the time to do that. Secant of 52, of course, is going to be 1 over the cosine. I messed that up. Try again. 1 over the cosine of 52 degrees. Still in radian or degree mode, right? It says degree mode up here. It's about 1.62. Let's write down, though, what we did put in the calculator, what we entered. Okay. This next question talks about domain, because, again, we've got reciprocal functions that have variables in the denominator. So there's that potential for them to be dividing by 0, right, and be undefined. So that's really what we're interested in. Why don't you consider again what cosecant is by looking up at the top, and think about which one of these angles would cause us to have an undefined cosecant, and therefore not be in the domain of this ratio, this function. Play the recording when you're ready. Okay, so hopefully you recognize that this is 1 over the sine of x. So when the sine is 0, we've got problems, right? We're dividing by 0. So there's a lot of ways you could consider that. You could think about your unit circle. When is the sine negative on our unit circle? That unit circle's hurting a little bit up here, right? It looks like it got squished. Or you could think about your sine graph. When is this graph equal to 0? So one way or another, try to figure out which of these angles is going to give us an undefined cosecant. Then play the recording when you're ready. So hopefully you realized sine is 0. Sine's the y value. So that's a point right there, although that's not a choice. That's a point right there as well. That is a choice. On our graph, that's a point, that's a point, that's a point. The only one that is a choice is 180 degrees. Okay. This next section we're going to talk about is when the quadrant, or what quadrant is the function positive or negative. So keep in mind, cotangent is the reciprocal of tangent. So cotangent is going to have the same positivity or negativity as tangent. So in quadrant 2, all students take calculus. What I should really be thinking about is, what is tangent in quadrant 2? Well, tangent is negative, therefore cotangent is negative. Why don't you work out B and C and play the recording when you're ready. Okay, so I would be thinking about all students take calculus. Secant in quadrant 4. So quadrant 4 is here. And secant in, well, basically whatever is going to behave the same as your cosine function. So cosine in quadrant 4 is positive. And because secant is just the reciprocal, it stays positive. So positive. Finally, all students take calculus. We're talking about quadrant 3. We're asked about the cosecant ratio, and the cosecant ratio has the same positivity or negativity as the sine. So sine, because the y value is negative, sine is negative. Therefore, your cosecant is also negative. By the way, just take a moment to pronounce these things. Secant is this one. Cosecant. Cotangent. We don't say cot. Sound like you don't know what you're talking about. Say cotangent. I'm going to skip exercise 5 in the interest of time and jump right down to exercise 6. This will be our last one we're looking at. So this is representative of the type of work I'm hoping we can do here in this course. I want to change this problem up. I don't want to be in terms of A and B. I'm going to actually put numbers on this triangle. I'm going to call this side length 8 and this side length 15. And based on that, I want you to find the hypotenuse, and then I want you to try to find the value of sine, cosine, and tangent. Because if you can find those three, I can get you these three very easily, because they're just the reciprocals of each of those. So pause the recording, work out your hypotenuse, and find your sine, cosine, and tangent. Play the recording. Okay, so do your Pythagorean theorem. C has to be 17. Now, find your sine, cosine, and tangent from the perspective of this angle A. And you can simply use your SOHCAHTOA. Nothing wrong with that. Okay, so hopefully you found all of these. Okay. Take a moment right now, based on what little you know, but you know a little bit. See if you can figure out cosecant, secant, and cotangent, knowing that they are the reciprocals of particular functions over here, and then play the recording when you're ready. Okay, so hopefully you came up with 17 over 8. You're saying, is it that easy? I thought it was hard. It's that easy. Once you have the sine, it's easy to find the cosecant. They're just reciprocals. The only time it would be challenging is if this had a radical in it and you had to rationalize the denominator. What I mean by that is we don't leave a square root, a radical of any sort, in the denominator. It's not considered simplified. So the next one would be 17/15, and the cotangent of A would just be 15/8. Thanks for watching.